and I think it's important to mention about 3D printing, is that people working on the scanning and characterization of the cochlear shapes, and we were able to get about 90 cochlears to be segmented out and fully characterized, which create the pool. And then out of the pool, we were able to check different properties and select the cochleas based on these extremes. So what I was interested in, looking at, average volume versus very big one, very small one. Then other aspects. In one of the papers we published, we look at one particular shape of the cochlea, and then we artificially change it. So we could measure the specific parameter and it change on the insertion force. That's also one of the things which we really, really like, and I think it's important to mention about 3D printing, is that it gives you ability to change just one parameter at a time and measure it multiple times, and then this way you create results which can be built upon. Because the problem is that if you start with complicated structure right at the start, and you get another complicated structure which has which is different in 5 different parameters, it's difficult to then measure which parameter actually plays the significant role and makes the biggest difference. So one thing we explore is that we took one average cochlea and then we artificially change one parameter at a time and measure the insertion force, 10 times, 100 times to get reliable data. And then we change another parameter again. And then this way we were able to compare the insertion forces between these different parameters and say which parameter is actually important.